Hello friends, I am Dr. Scott Feiser. I welcome you in my YouTube channel. Today in this video, I am going to talk about UV visible spectroscopy, especially Woodward Fieser rule. It is used for calculating the absorption maxima. Woodward 1941 gives certain rule for correlating lambda max with the molecular structure. These rules are modified by Scott and Feiser. This rule for calculating lambda max is conjugated dienes, trienes and polyenes, homoannular dienes, cyclic dienes having conjugated double bonds in the same ring. So homoannular dienes, cyclic dienes in which double bond in conjugation are present in different ring. Endocyclic double bonds, it is the double bond present in ring as shown. An exocyclic double bond in which one of the double bond atom is the part of the ring system. So you can see the heteroannular dienes and you can see the exo double bonds and endocyclic double bonds. So parent value acyclic and heteroannular conjugated dienes 250 nanometer, homoannular conjugated dienes 253 nanometer, acyclic trienes 245 nanometer. Increment each alkyl substituents or ring residue 5 nanometer, exocyclic double bonds 5 nanometer, double bond extending conjugation 30 nanometer, oxochromes OR 6 nanometer, SR 30 nanometer, Cl and Br 5 nanometer, NR2 60 nanometer. So problem 1,4-dimethyl cyclohexane 1,3 dienes. So parent value for homoannular dienes 253 nanometer, 2 alkyl substituents 2 into 5 10 nanometer, 2 ring residue you can see here 2 into 5 10 nanometer. So calculated value 273 nanometer and observed value 265 nanometer. Now in the second example, parent value for heteroannular diene 250 nanometer, 4 ring residue 4 into 5 20 nanometer, calculated value 235 nanometer and observed value 236 nanometer. Now Woodward Fieser rule for conjugated dienes and alpha beta unsaturated carbonyl compound. So parent value alpha beta unsaturated acyclic or 6-member ring ketone 250 nanometer, alpha beta unsaturated 5-member ring ketone 202 nanometer and alpha beta unsaturated aldehyde 207 nanometer. Increment each alkyl substituent or ring residue at alpha position 10, at beta position 12 and gamma position 18 nanometer. Each exocyclic double bond 5 nanometer, double bond extending conjugation 30 nanometer, homoannular conjugated dienes 39 nanometer, oxochromes and position alpha, beta, gamma, OH, OR, SR you can see 35, 30, 50, 35, 30, 70 and so on. Now problems A alpha beta unsaturated acyclic ketones, parent value 250 nanometer, 1 alkyl substituents in alpha position 10 nanometer, calculated value 225 nanometer, observed value 220 nanometer. Parent value for alpha beta unsaturated 6-member cyclic ketones 250 nanometer, 1 ring residue at alpha position 10 nanometer, 2 ring residue at beta position 2 into 12 24 nanometer, double bond exocyclic to 2 rings 2 into 5 10 nanometer, calculated value 259 nanometer, observed value same. Now friends, you can see this is the parent chromophore and their value. So parachloroacetophenone is an important compound, basic value 240 nanometer, Cl substituent at para position 10 nanometer, calculated value 256 nanometer and observed value 254 nanometer. So what is the applications? Extent of conjugation, distinction between conjugated and non-conjugated compound, detection of chromophore in an unknown compound, identification of chromophore functional groups, study of strain study of geometrical isomerism, study of tautomerism, study of structural feature in different solvent, structural feature in different solvent as an analytical tool. So friends, hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.